Life on Earth is one of the greatest mysteries of science. How did life arise on our planet? Was it a unique and random event, or is it possible that life arrived from other places in the universe? One fascinating theory that has been debated for decades is panspermia, which suggests that life may have arrived on Earth from elsewhere in the universe. What is panspermia? Panspermia is a hypothesis that suggests that life on Earth may have arrived in the form of microscopic organisms carried by comets or asteroids. According to this theory, these organisms could have arrived on Earth thousands or even millions of years ago and evolved to give rise to the diversity of life we see today. How panspermia works. Panspermia proposes that life originated somewhere in the universe and spread through space, transported by comets and asteroids. These objects could have traveled for millions of years before colliding with Earth and depositing the microscopic organisms on our planet. It is believed that this occurred in the Precambrian era, before the dinosaurs, around 4.5 billion years ago, which is believed to have been extremely bombarded by celestial bodies. One of the main proponents of this theory was Svante Arrhenius, a scientist awarded the Nobel Prize in Chemistry in 1903 who coined the term to explain the origin of life. His ideas were related to particles, propagules or vital seeds, that were extremely small, traveling through the cosmos, propelled by forces derived from solar energy, which may have accidentally reached our planet and filled it with life. These seeds, according to Arrhenius, would have reached the Earth's surface, probably with favorable conditions for their germination, and would have given rise to the first forms of life, which would have then evolved into the more complex forms we know today. How would they manage to survive in space? Once in space, these resilient travelers can easily deal with the cold and lack of oxygen. Even normal bacteria, under extreme conditions, can enter a state of dormancy, creating safe spaces surrounded by thick walls, packages of heat-resistant bacterial DNA, and able to withstand cold, dryness, acidity, and ultraviolet radiation while traveling through space. Another obstacle is time. Space is vast, so traveling anywhere takes a long time. That being said, in 2020, Japanese scientists revived bacteria that had been dormant on the ocean floor for 100 million years, so perhaps the extraordinary distances may not be a problem for these tiny space travelers. The final step is surviving the crash landing in their new home. And it has been shown that bacteria can do just that, as long as they are housed in deep fractures in cosmic rock. Although panspermia is still a hypothesis, some evidence supports it. First, organic molecules have been detected on other planets and moons in our solar system, suggesting the presence of materials necessary for life. Additionally, it has been discovered that some asteroids and comets contain water, which is essential for life as we know it. One of the events that supports this theory is the meteorite ALH 84001, which was discovered on December 27, 1984, by an expedition from the American Smithsonian Institute in Antarctica, which, unlike other meteorites found in Antarctic lands, provided evidence of bacterial fossils and organic molecules. It is also known that there are different types of panspermia. The first is known as natural panspermia, which states that life spreads through bacteria with high resistance aboard comets or meteorites, and is the most accepted. Then there is molecular panspermia, in which it would not be bacteria that travel, but organic molecules that, when in contact with the primordial amino acid soup, give rise to life through chemical reactions. Finally, the least orthodox theory of all but not least interesting is called directed panspermia. Francis Crick, a molecular biologist and neuroscientist who discovered the DNA molecule with James Watson and Rosalind Franklin, said that life originated when a more advanced civilization from another part of the cosmos deliberately sent organisms to other planets, with Earth as we know it today being one of them. A team of prominent scientists from MIT and Harvard, for example, are so sufficiently convinced of the plausibility of panspermia that they have invested more than a decade, and a good amount of NASA and other funding, to design and produce an instrument that can be sent to Mars and potentially detect DNA or the most primitive RNA. However, some argue that it is unlikely that microscopic organisms would survive in space and arrive on Earth in viable conditions. Additionally, Panspermia does not explain how life arose in the universe in the first place, but simply shifts the problem elsewhere. Panspermia is an intriguing hypothesis that raises fascinating questions about the origin of life in the universe. Although there is still much to learn and discover, Panspermia offers an exciting and challenging perspective on how life may have arrived on our planet. Was life on Earth a unique and random event, or is it possible that it is part of a larger and more complex process that has developed over time and in different places in the universe? The answer is still to be discovered.